Hi, my name is Tom Walski from Bentley Systems, and I'm here in my role as a member of the Water Distribution System Analysis History Committee of the Environmental and Water Resources Institute. It's May 24th, 2016, and we're in West Palm Beach, Florida for the EWRI conference. And today we're going to be interviewing Dr. Zheng Wu, who's also from Bentley Systems. Zheng and I have collaborated on a good bit of work together, and he's been a real pioneer in the area of water distribution system analysis techniques, or optimization techniques applied to water distribution system analysis. So, Dr. Wu, how did you first get involved with water distribution system analysis?
Well, my early career, by training, I was a hydronic structure engineer. So I was involved in hydronics and hydronic structure design. But my real turning point was when I awarded Netherlands fellowship going to UNESCO IHE. I started hydroinformatics from 92 to 94, and where I taught myself genetic algorithms and applied to water distribution system and also sewer system. Later, I went to Danish Hydronic Institute in Copenhagen, in Denmark, and I did a short project for DHI applying the genetic algorithms to sewer system modeling, including hydronics and hydronic model calibration. And I was fortunate that I was awarded a scholarship and did my PhD in water distribution system analysis with Dr. X. Simpson in University of Adelaide, and that was how I got involved in water distribution system analysis.
Okay, so you've taken that and done quite a bit of really interesting work. What would be your most memorable project that you ever worked on?
I found that it was very interesting and rewarding working with water utilities around the world, applying and the state-of-art water distribution system analysis tools. And one of the projects I've been working on for quite many years, since 2005, was working with United Utility in UK. I started that with the hydronic modeling and team there with UU. We work with a number of engineers and applied our optimization to identify niche hotspot, where we did a lot of case studies, and then we found that we can improve the niche detection efficiency by applying those tools. And that was really a good study, and I have learned a great deal from the practitioners.
Yeah, you did a book on, both as an author and editor of a book on water loss reduction. How was it working with among yourself and the other experts in this field? How was that experience?
Yeah, that was another great working experience, working with not just water utility practitioners, and also with a group of experts from industry and also universities. I was lucky to work with those people. We come together, work out our own chapters, and each of those chapters each individual expert are specialized in. So we put together a group of people. We wrote the book, and I was taking the lead to as a technical editor, and we published that book in 2007. So that book is a very good piece of work for me and also for many people. And together we made that contribution to the water distribution system community.
So what is your role nowadays with Bentley Systems, and how did you end up where you are now as the lead researcher?
My current role, my working title, let's say, is a Bentley Fellow, and my primary responsibility is for managing and conducting applied research for Bentley System. Now, a Bentley System has a variety of the software for infrastructure, including water distribution system analysis. Of course, that was my primary domain. We apply emerging technology from information technology to solve and address the challenge problems in infrastructure industry, including water distribution system.
Okay. So you talked about emerging technology. So where do you see us going in water distribution system analysis? What do you see the future looking like?
We have seen a few new trends in information technology, in computing, and also in sensing technology. And for instance, we have been working on cloud computing. And this is something we identified a few years ago as one of the emerging technology, because the cloud computing make it possible for ordinary people or small companies or large to access the powerful computing capacities through the cloud. So high-performance computing, supercomputer used to be some luxury computing facilities for large research organizations, but with the cloud, and it made it possible for everyone to access that computing power. And that's a new thing. Another thing is we have seen a lot of advancement in sensors and monitoring technology that becomes very affordable. And it means that we will see a lot of monitoring and sensing technologies applied to water distribution system. So we will have a better data and to understand how the system works. And another new thing we have seen is machine learning. Over the last few years, we have seen the great breakthrough in machine learning, such as deep learning, and we heard those great breakthroughs like AlphaGo and beat the human champion in the world. And those techniques can be applied to analyze those large data set for water distribution system. So those three trends will converge, and we will see many more new development in applying the machine learning to deal with the monitoring data through the cloud computing. So we will see a lot of research and breakthroughs in data-driven analysis. However, this is not going to happen automatically. This will require water distribution system practitioners, like those people from water utilities, and also the academic research and software vendors like us to work together to make this happen.
Okay. So over your career now, you've seen a lot of the history of water distribution systems. So any kind of final word about how the history has evolved?
I think it has been a great advancement over the last 2 or 3 decades for water distribution system analysis, and especially with the ITs, with new computing powers, and that enables a lot of new opportunities for water distribution system researchers and also for practitioners. In the future, as I just mentioned, those three trends, cloud computing, monitoring and sensing technology, and machine learning will come together to involve that history into the future.
Okay, well, thank you, Dr. Wu, for your time to share your history and your experiences, and we appreciate your contributions.
Thank you very much.